Alright, so today we are doing Amsti 6.1, where we are doing electrolysis of water. So we are basically taking water and separating it into hydrogen and oxygen gas. I need to take a little more out of this one and put it in here. Okay. So the only way to do that is to have your setup with batteries. Okay, so I'm going to add an electrolyte to both waters. I have to put 2 scoops of the electrolyte into the water. Why do you think we need electrolytes in the water? Yes, to make it more conductive. Okay. All right. Stir this up a little bit. Make sure it dissolves. Alright, can y'all see it's kind of cloudy now because I've got the salt in it? You can't see?
I can see it.
Well then move. If you can't see, you can move closer.
Okay. It looks like looking at water.
It does kind of, doesn't it? Okay, now I'm going to set my electrode back in there. I'm going to stir this one up. They are both going to be exactly the same. Yeah, I'm doing 2 because usually every year I have one that will work great and one that won't. So I'm not taking my chances with one not working, so I'm going to do 2. I hope they both work. That would be awesome, wouldn't it? One's going to be positive, one's going to be negative. You'll see. And I'm going to set...
Teachers, I have just a few announcements real quick. The band students will still have practice after school today. The sign-up sheets for dance line and color guard are on the band room door by the front office if you're interested. And there's some testing about to begin in Miss Willingham's class. So as you go to PE, please be very quiet. Thank you.
All right. So, who remembers which one of these electrodes, red or black, goes to positive?
Red.
Red. Red goes positive. Okay, so we're going to plug in our red here. Okay. Tell you what. No, I have to do it that way. All right. And so that means that the black goes to negative. Plug in our black to negative. We'll do the negative one on this one. Okay. And then before I connect them, I'm going to go ahead and put my 2 little test tubes on top of the electrodes. There's these little screw things on top of the electrodes that the test tubes fit on top of, and that's what collects the gas. So I'm going to submerge my test tubes and then invert them on top of the electrodes like that. And if you want to come up here and see what it looks like, you can. Just be careful and do not knock them over. Okay, you see how I've got them inverted on top of the metal electrodes? I'm going to get all of the air bubbles out. All right. Now, those are ready to go. So when I connect these two electrodes, we should start seeing some bubbles appear. Okay, now I want you to come up here and take a look. I'm going to put my camera so you can clearly see that there's bubbles.
Yo, that's math.
You can see the bubbles in the positive and the negative electrodes.
Which one?
Okay.
Which one is which again?
The negative is black, positive is red, yes.
Oh, okay.
So it looks to me like the negative is moving faster than the positive. Okay? Alright, once you've seen it, y'all can go back and sit down. So, when you sit down, okay, after you sit down, we need to go ahead and write down for number 1. It says, what do you observe happening at each electrode? What did you see happening? Yeah, well, it's because it's bubbling so fast. So you see bubbles in both of them, okay, but the negative one is bubbling faster. And we'll go over why in a little bit. Yeah, the positive one is also bubbling. It's just a little bit slower. And we'll talk in just a minute why the negative one bubbles faster than the positive. Okay, when we get a little bit farther on in the electrolysis, we will discuss question number 2. Alright, so now we've got one of our electrodes is just about ready to test. So let's go back and look at question number 2. It says, what do you observe about the volumes of the two substances collected in the tubes? Okay. If you cannot see, come up here and look, but one of them is almost completely empty, and one of them is about 2/3 or about a third done, okay? So the negative electrode is the one that is finished.
Hey, can I get easy, please?
Yeah. The positive electrode is the one that is still working. It's not finished yet. Okay? So, go ahead and write down on question number 2 that the negative electrode is the one that's already finished. And the positive electrode is the one that is still working. Okay? All right. Now comes the fun part. We get to test which gas is in which tube. Okay? So I'm going to go ahead and test this one right here first. This is our first one that's finished on the negative electrode. How am I going to do this? I need a volunteer. Okay, saw William's hand first. Come here. You're not going to be on video either. Okay, now this is going to be tricky. Okay, we're going to do this one. I'm going to take it off the electrode, and you are going, before I take it out of the water, you're going to stick your finger over the top of it, and you're not going to take it off until I show you to.
I'm glad I didn't volunteer with this.
Okay. Put your finger underneath it. Okay. Put your other finger there. Now flip it over and do not take your finger off until I tell you to. All right. Now hang on, because we're going to get it on video. Just the two.
Video.
Okay. So we're going to put just the tube on the video. I'm going to light this. Okay. Y'all ready? Okay, let go. Did y'all hear the pop?
Mm-hmm. Sounded like math.
Did you hear the pop? Yeah. Okay. So go ahead. You've got to do that in your table for test with a burning splint for the gas collected at the negative electrode. Tube 1 pop. Okay, so now let's think about the formula for water. What is the formula for water?
H2O.
It's H2O. Well, what does that mean? How many hydrogen atoms do you have for every oxygen? You've got 2. 2 hydrogen for every 1 oxygen. So, which one of these do you think was at the negative electrode? Think about it. Why did one move faster than the other?
Math.
Yeah, because you got more hydrogen atoms. You've got 2 hydrogen atoms for every 1 oxygen. That means that your hydrogen gas was at the negative because it was moving twice as fast as the oxygen. Does that make sense?
Yeah.
Because if you've got 2 atoms of gas for hydrogen for every 1 of oxygen, then the hydrogen is going to fill it twice as fast as the oxygen will. Okay? So, number 4, 4A, what's the name of the gas produced at the negative electrode? Hydrogen. I just told you. And B is actually supposed to be positive electrode. What's the gas produced at the positive electrode? Yes, oxygen. All right, now let's go ahead and do 5 through 8, and then we will come back and do our oxygen gas in just a minute because it's not quite finished. Okay, so number 5, what are the 2 gases that make up water? Hydrogen and oxygen, okay? And number 6, do you think that water is an element or a compound? It's what? I heard somebody say it.
Compound.
It's a compound. Do you know why it's a compound?
Because it has 2 different.
Well, you've got 2 different elements that are chemically bonded together, okay? That's what a compound is. 2 elements that are chemically bonded together. All right, number 7. What is the ratio of the volume of hydrogen to the volume of oxygen? It's 2 to 1. You've got 2 hydrogen for every 1 oxygen. And I've already answered number 8. It says water is written as H2O. What do you think this formula means? It means you have 2 hydrogen for every 1 oxygen. That's what it means. All right, we should have enough oxygen gas now in one of them to go ahead and test it. Who wants to be my volunteer this time?
Can we go twice?
Andrew, come on. All right. Okay, I'm going to take it off.
Oh, I can't get it yet.
Put your finger, don't take your finger off of it, flip it over, don't take it off yet, okay?
got this.
That was easier than I thought.
It's just, I can't do it,
Is it busting, you know?
hold on a second, let me make sure I get this video
Lower.
in the right spot. Not that close, not that close. Back up a little bit. Okay. end the video, and I apologize. Okay, I've got to get this lit good.
I burn my finger.
No, I'm not going to burn your finger. This one's a little different. Okay.
I'll let go.
Not yet.
Okay.
Okay, now. Okay, did y'all see that light back up and it kind of had a little pop to it too? Did y'all hear that and see it?
I didn't see it.
Okay, when I stuck it was a glowing splint this time. I stuck it down in there, and what does oxygen do to a fire?
It makes it bigger.
Yeah, it fuels a fire. It makes it bigger. So when I put a glowing splint down in there, it like lit it back up. And I burned up all the oxygen, and it went out when all the oxygen was burned up. Okay, thank you, Andrew. Okay, who wants to do my last one? Okay, come on, Michael. Okay, take it off. Put your finger into the water. It's not gonna shock you. Put your finger,
It's gonna shock you.
put it on top, put it underneath the test tube. No, you've got to like hold on to it.
Hold on.
Yeah, and now hold on to it with your thumb and flip it over. Can they wait about 5 minutes? Okay. Yes, I will tell you when to. Okay. Okay, go over here so we can get it on camera again. Yeah, that's good. All right, now y'all watch this time. Okay. Did y'all see it that time? Okay. Sorry. It did. It lit back up. And it made like a little bitty pot. You can still see the smoke in there, see? It had a little smoke in there. All right. Thank you, Michael.